Okay, let's take a look here on page 304 in the blue textbook. We are going to be looking at what's called indirect measurement, or finding a missing measurement when given three other measurements. Native Americans of the Northwest, such as the Tlingit tribe of Alaska, carved totem poles out of tree trunks. These poles, sometimes painted with bright colors, could stand up to 80 feet tall. Totem poles included carvings of animal figures such as bears and eagles, which symbolized traits of the family or clan who built them. Measuring the heights of tall objects, like totem poles, cannot be done by using a ruler or a yardstick. Instead, you can use indirect measurement. And here's another vocabulary word to add to your vocabulary list. Indirect measurement is a method of using proportions to find an unknown length or distance in similar figures. So in the previous video, we talked about determining whether a figure is similar or not. Well, in this particular lesson, we're going to be given similar figures, and we've got to find a missing measurement. So look at triangle ABC and triangle JKL. They are similar, and I know that because it's telling me right here there's that similar symbol. And it asks me to find the unknown length. So I am looking for X here. We can find X by doing proportions. Remember, if two figures are similar, their corresponding angles are congruent and the corresponding sides are proportional. So what I would like to do is I'd like to take and find two ratios of corresponding sides, and one of them has to have the missing measurement in it. So since X is our missing measurement, we got to ask ourselves, is this side the medium, the large, or the small side of this triangle? So I'm going to come over here and go, okay, small angle means small side. So this is the small. This is an obtuse angle. That must mean my largest angle. That means 56 is my largest size side. That must mean X is the medium size side. So I need to compare medium size sides, and I always want to, if at all possible, use the small side as well. So over here, 8 centimeters is going to be my smallest side. So I'm going to put 8 on the top, and then I got to put the smallest of my second figure on the bottom, which is the 28. So 8, the smallest of my first figure, over 28, the smallest of my second figure. And then because I have to use the medium-sized side, I'm going to use 12, the medium-sized side, over here, and put it over X, the medium-sized side over there. Now I just have a proportion. How do we solve proportions? We cross multiply. 8 times X will be equal to 12 times 28. I want to divide both sides by 8 so that my 8's cross out, and then X equals, and so I'm going to reduce 12 and 24, or 12 and 8, excuse me, to 3 and 2 by dividing them both by 4. 28 divided by 2 is 14, and 3 times 14 is 42. So I'm going to come up here, and I'm going to make sure that 42 is my medium-sized side. 28 was my smallest, 56 was my largest, 42 comes between 28 and 56, so I can feel confident that my answer is correct, that 42 centimeters is the length of that side. Take a look at this comparison of a Olympic-sized pool with a rectangular volleyball court. Well, it's saying they're two similar figures. So this is actually easier than the triangles because there's only two sides on a rectangle. You have 9 and 18, 9 being the smallest and 18 being the largest. So since we put the first figure on top, I'm going to put 9 on top and 18 on top of my two ratios. I am missing the small size side of the pool, So I'm going to put, I don't know, W for width on the bottom here, and 50, the larger size side, I'm going to write on the bottom over here. So 9 small side to W small side, that I don't know, is equal to large size 18 to large size 50. I cross multiply, I get 18W is equal to 9 times 50. I divide both sides by 18. 18 and 18 cross off. 9 goes into 18 2 times. 50 divided by 2 is 25. And again, I want to make sure my answer makes sense. 25 meters is the width of the pool. That's smaller than 50 meters. And actually, when I look at them and compare them, 9 is half of 18. 25 is half of 50. So the answer makes sense. Take a look at this. This is the most common use of indirect measurement when you have something tall like a tree, or in this case, a birdhouse. We want to know how tall that birdhouse is. We can actually go out and measure the shadow of it, and then measure something that is short enough to be measured, like this girl. This girl is 5 feet tall, and her shadow is 3.75 feet tall. When I set up my proportion, I want to set this up as height of the girl over the height of the birdhouse. So height of the girl over height of the birdhouse would be 5 feet over h. And then I want to put the shadow of the girl, because the girl's got to go on top, which is 3.75, over the shadow of the birdhouse, which is 15.5. So remember, when you write proportions, same things on top, same things on the bottom. Situation 1 on the left, situation 2 on the right. Well, in this case, the situation is the height or the shadow. So when I take out my handy dandy calculator, I am going to cross multiply. 3.75 with h has got to be equal to 5 times 15.5. I divide both sides by 3.75, and I am not going to even bother to try and reduce anything here, because that's way too difficult of mental math, even for me. So I'm going to do 5 times 1, whoops, I made a typo, 5 times 5.5 divided by 3.75. You definitely want to make sure that you type this in correctly. I got a repeating decimal when I did that, so I'm going to double check my work. 5 times 15.5 divided by 3.75 equals, and I got the same answer. So it is approximately 20.6 repeating, so I would say it is approximately 21 feet tall. And I'm going to look over here and go, does that answer make sense? Well, the girl is 5 feet tall. The birdhouse is taller. The girl casts a 3.75 shadow. The taller birdhouse casts a 15.5 feet shadow. The shadow of the girl is shorter than she is. The shadow of the birdhouse is shorter than the birdhouse is. So yes, this answer makes sense. That gets you up to the guided practice on page 306. I would like for you to attempt this work. Be very careful with these two triangles. They are not facing the same direction. Remember, you want to compare small side to small side, medium-sized side to medium-sized side, and large size side to large size side. We will come together at the end of the class and go over these problems.